So now let's have an overview with operation strategy. First, the quality. Quality is a major consideration for virtually all customers. So achieving and maintaining quality standards is of strategic importance to all business organizations. Let's give an example. Barcodes might cut drug errors in hospitals. Again, it might cut only. It's estimated that more than 7,000 hospital patients die each year because of drug errors, and many others suffer ill effects from being given the wrong drug or the wrong dosage. Some hospitals are using barcodes attached to patients' wristbands that allow hospital personnel who administer drugs to patients to electronically check to make sure the drug and dosage are appropriate. Before administering a drug, the doctor or nurse scans the barcode attached to the patient to see what drug is needed and when, and then the drug's barcode is scanned to verify that the medication is correct. But barcodes are not foolproof. As a recent study of hospitals showed, nurses may develop a workaround that involves using photocopies of a group of patients' barcodes, which are then used to obtain drugs for the entire group. The nurse will then have a tray that may contain drugs of different dosages intended for different patients. At that point, the barcode protection has been circumvented. So here, the quality of barcodes is not the issue. It's the nurses who did not use it right. If the inspection is absent here, the wrongdoing of the nurses will continue. Now, let's describe inspection and statistical process control, which is under quality control. For appraisal, we have inspection, which means examining the output of a process to determine whether it is acceptable. The key issues here include where to inspect in the process, how often to inspect, and whether to inspect on-site or in a laboratory. An example here is an auditing in a restaurant. They do inspect the whole restaurant, and that's an inspection on-site and not in a laboratory. Next, for statistical process control, which focuses on detecting departures from randomness in a process, there are two basic tools of process control: the charts and the run test. For charts, there are measurement of data. For run tests, we have median and up or down tests, and I will discuss it later. I will end the discussion of process capability, which used to determine if the output of the process will satisfy specifications. They can provide valuable information for managers in terms of reducing costs and avoiding problems created by generating output that is not within the specifications. Again, in process capability, they avoid problems that create generating output which is not within the specifications. Let's move on with the summary of formulas which have been discussed earlier. Yes, there. And for control charts for means and ranges. An example here. Processing new accounts at a bank is intended to average 10 minutes each. 5 samples of 4 observations each have been taken. We will use the sample data in conjunction with table number 10.2 to construct upper and lower control limits for both a mean chart and a range chart. So for sample 1, we have 10.2, 9.9, 9.8, 10.1 with an average of 40. So let's move on with the mean and range. In sample number 1, we have a total average of 40. We will, yes, over here, 40. And we will divide it in 4 because we have 4 examples of observation in sample number 1. And then we will get the mean of 10, and for the range we will have to get the highest and the lowest observation. The highest in sample number 1 is 10.2 and the lowest is 9.8. So 10.2 minus 9.8, we will have a 0.4, which happens to be our range. And that's all. And later we will give an examples of solving formulas for process capability. Thank you.